Guys, continuing on from the class opener, this is what we're doing today. We're taking a monomial and multiplying it by a polynomial. In this case, we have a linear monomial times a quadratic binomial. Now, you don't need to do that. I'm just saying it not to show off, but so you could get more comfortable with the vocabulary, right? It's a linear monomial because the power of one term, multiplied with a quadratic because the power of the degree 2 is a quadratic binomial, 2 terms. So again, we're simply going to distribute negative 2h times negative 7h squared. That becomes negative 14h to the third. And then you distribute it over here, 2h times negative 4h. Well, 2 times negative 4 is negative 8. H times h is h squared. Easy, right? And that's it. Now, just for funsies, if I asked you classify it, what would that be? Cubic binomial. Now, it doesn't say for you to classify it on the instructions, but you know, might as well. It's fun. Let's not classify 3 because it has multiple variables. Let's not even mess with that. But let's actually do number 3. So you're going to take the 5jk, just kidding, and we're going to distribute it to the 3jk and the 2k. So when I multiply 5 times 3, I get the 15. And when I multiply j times another j here, what do I get? J squared, or j to the second. Now when I multiply k times k, what do I get? K squared. And now we need to distribute it to the other term, right? Take it and distribute it to that second one over there, the plus 2k. So when I go 5 times 2, I get that positive 10. And when I take the j times, there's no j, so I'm just going to bring that j right down. And last but not least, k times k, well, that's going to be a what? K squared. And that is your answer right there. And of course, the answers are on the back. I'm not going to even bother classifying that one because it has multiple variables. And I think on this video, I'm just going to do the odd ones. I'll do another video with the even ones. Some people freak out with fractions. Don't. It's okay. Let's actually distribute the negative 1/4 m times 8m squared. So if you're really confused with this, actually show your work. You could say negative 1/4, negative 1/4 times 8, and then you could put this m and that m together, say m times m squared. So when you look at the 1/4 times 8, or the negative 1/4 times 8, you could put the 8 over a 1 and multiply top with the top, bottom with the bottom, and you'll get negative 8 over 4, which becomes negative 2. Or you could cancel right from the beginning, 8 on top, 4 on the bottom, you have 2 left up on top. And negative 1 times 2 is negative 2. And then the m times m squared, that's going to be a m to the third. So when you distribute negative 1/4 m times 8m squared, it gives you a negative 2m to the third. When you distribute negative 1/4 m times positive, there's an invisible 1 right there, m, that's pretty easy because negative 1/4 times 1 is still going to be negative 1/4. And then you have the m times m. What's m times m? M squared. And last but not least, negative 1/4 m times that negative 7. If you want to show your work, go for it. You could say negative 1/4 times negative 7, and you could put the 7 over 1. And you really can't do anything there. The 7 doesn't cancel with the 4. The only thing you could do is say a negative times a negative is a what? Positive. So you could put plus, and then multiply 1 times 7, that's 7, and 4 times 1, that's 4. And believe it or not, that's your answer. And it's okay to have a fraction as your constant. Okay? As a matter of fact, let's classify this guy since it's only one variable, variable m. If I were to classify it, what would it be? First and last name? Cubic trinomial. But that's your answer. Check the back. That's the answer you have. Negative 2m to the third, negative 1/4 m squared plus 7/4. Let's move on to number 7. Down here it says simplify each expression. So we're going to be distributing first and then combining like terms later. We've already done this in the past. Negative 2L times 3L, that's negative 6 what? L squared. Perfect. Negative 2L times negative 4, what's that? Positive 8L. And then let's bring down the plus 7L. Now out of those three terms, 1, 2, 3, you could combine the last two, this guy and this guy, combine them, you'll get 15 of those L's. And it is positive 15 of those L's. And let's bring down the first, negative 6L squared. So that's my answer. If you check the back, that's what it is. In addition to that, just for practice, to get you guys more familiar with the vocab, what's the classification of this? Quadratic binomial. Moving on to number 9. Well, look at that. Number 8's fun. Oh, number 9's fun too. Because there's distributive property here, and there's distributive property over here, and then at the end of it all, you're going to be combining like terms. Fun stuff. Number 9, it requires distributive property and combining like terms. We've already done all this kind of stuff before, but now, of course, we have exponents involved. So when I look at number 9, I'm going to distribute the 6t first. So 6t times 2t, 12t what? To the second, right? Because 6 times 2 is 12, and t times t is t squared. Okay, so I've distributed there to the 2t. Now let me distribute 6t times negative 3. What do I get? Negative 18 with the t. All right, perfect. Now let me distribute this minus 5. Minus 5 times 2t, what do I get? Negative 10 t to the second. Why to the second? Because there is no t's here. If it were a 5t, then yeah, the negative 5 times 2 is negative 10, and the t times t squared would be t to the third. But there is no t, it's just t squared comes down. And let's continue distributing first before combining like terms, because remember, PEMDAS, multiply before adding or subtracting. So multiply negative 5 times positive 9 with a t, that's going to be a negative 45 with the t. And then last but not least, negative 5 times negative 3, positive 15. Ladies and gentlemen, we have distributed. That's multiplying. Now we move on to adding or subtracting, which is combining like terms. Let's start with the highest exponent term because we want our answer in standard form. We're going to take this 12t squared and combine it with negative 10t squared. And notice that I include the sign that's in front. That tells me if I have or I owe. So I have $12 or I have 12 cookies or whatever you want to call this. I have 12t squares and I'm going to take away 10t squares. What do I get? 2t squares. So remember, when you're adding or subtracting, exponents don't change. It's only when you're multiplying when exponents change. Moving on to the t's. I have negative 18t with a minus 45t. That's going to be a minus 63t, correct? So you're going to put minus 63t. And last but not least, let's combine the numbers with the numbers. And there is no other number besides that constant 15. So I'm going to bring down that constant 15. Ladies and gentlemen, if you check the back, that should be your answer on number 9. And just for funsies, we are going to classify our answers when we have single variable polynomials. So what would this classification be, first and last name? Quadratic trinomial. Now, the homework here is not asking you to do this, but I want you to get as fluent as you can with these words, right? Let's move on to number 11. Look at that. Look at that beauty right there. Where? Number 11 is beautiful. I don't see it. It's my papers didn't have it. So sexy. Okay, so we're going to distribute first. Okay, we're going to distribute first. And we're going to go to each item and distribute one piece at a time. So I'm going to go negative 3g times 7g. What do I get? Negative 21g squared. And then negative 3g times negative 2. Negative times a negative? Positive. Positive what? 6g. Perfect. Let's move on to the next distributive property here. on the plus 3. I want to distribute this plus 3. 3 times g squared plus 3g squared. 3 times 2g, positive 6g. 3 times 1, 3. All right, and last but not least, we have another distributive property situation over here. The minus 3g times minus 5g. What's minus? Positive 15g squared. Minus 3g times positive 3, negative 9 with a g. We've distributed 3 times on this beautiful problem. And it still looks ugly, but we could now make it look better by combining the terms that are alike. We want standard form. Let's start by doing all the squares first. Let's do negative 21g squared plus 3g squared. What's that so far?
18g squared.
That's negative 18g squared so far. And then negative 18g squared plus 15g squared, negative 3 of those g squares. And if this is complicated for you, you could get a calculator and do negative 21 plus 3 plus 15, and it should give you a negative 3. And just remember that we're talking about g squares. So just put the g squared there. Let's move on to our regular g's now. I have plus 6g, what's that so far? 12g minus 9g? 12g minus 9g?
3g.
3g. That's positive 3g. And finally, our constant values, our numbers without variables. Is there any of those? Yeah, just this 3 right there, so you just bring it down. And that's your answer. And just for funsies, classify that. It's going to be a quadratic, trinomial. Now, that's all fun and great, but we do need to go back and review semester 1 stuff, which is solving that require these multi-step simplification, right? So we're going to have equations, and we're going to solve them. And if you don't remember, let's review right now. You simplify the left side, simplify the right side, rewrite your simplified equation, and then worry about getting x by itself, or in this case, u. So if we take a look at the left side, let's distribute 3 times 3u. What do I get? 9u. How about 3 times 2? 6. Bring down the plus 5. Is there anything else I could do after distributive property?
11.
Yep, combine like terms and get 11. So I now have 9u plus 11. This equal sign is going to come straight down. And now I need to simplify the right side. 2 times 2u is 4u, and for me. And 2 times negative 2, negative 4. And this is your new simplified equation. Now you could worry about getting u by itself on one side. Now the thing is, yeah, you don't want u's on each side. So let's get rid of one of them. Which one do you want to get rid of, the 9 or the 4?
The 9.
Oh, the 4. No, the 9.
You can get rid of whatever you want on your paper. There's many roads to the same place. But I think it'll be a little nicer to get rid of this 4u, because what I do to one side, I do to the other side, subtract 4u, and I'll get a nice positive 5u. Bring down the minus 4 on the right side. And now let's get u by itself on the left side. Subtract 11. Subtract 11. You're going to end up with 5u equals negative 15, which means that your final step would be to divide by 5 and divide by 5, which means u equals negative 3. U equals negative 3. And again, the answers are on the back. You should be checking your work as you go. I don't know if you've noticed, but on this video I'm doing the odd ones only. But on number 15, we need to distribute, combine like terms if possible, and then worry about getting b by itself on one side. So when I distribute 8 times 3b, that is 24b. When I distribute 8 times 1, that is 8. Bring down the equal sign, and now let me distribute and combine like terms on the right side. Since there's nothing left to do on the left side, I now move on to the right side. So let's distribute 4 times b, that's 4b. 4 times 3, that is 12. But I still have the minus 9 at the very end. So before solving, I need to do combining like terms after distributive property. So I could combine the 12 with the minus 9, and that'll give me 3. So my new equation, the left side stays the same, 24b plus 8 equals 4b plus 3. Now let's get b by itself on one side. Subtract 4b, and you will have 20b plus 8 equaling 3. Final step, subtract 8, you will have 20b equals negative 5. I'm running out of space here. 20b equals negative 5. So what's my final step here? Divide by 20. Sorry, I ran out of space. So my answer is b equals negative 5 over 20. However, you could reduce negative 5 over 20. You could reduce it by 5. If you reduce by 5, you'll get negative 1/4. And it's okay to have fractions as answers, especially on equations. Any questions on that? Let's do the last odd one, number 17. Distribute, combine like terms, simplify your equation, then worry about getting u by itself. So when I go u times u, what do I get? U squared. When I go u times negative 5, what do I get? Negative 5u. And then bring down the plus 8u. So I have distributed. Now I need to combine like terms. Out of those 3 terms, I could combine the negative 5u with the 8u and get what? Bless you. No, you don't get bless you. You get 3u, right? So we're going to end up with u squared plus 3u. If you owe 5 and you have 8, you're going to have 3 left over. That's as far as we could go on the left side. Now let's do the right side of this equation. U times u? U squared. U times 2? 2u. Bring down the minus 4. Out of those 3 terms, could you combine any of those? No, you cannot, right? They're all different terms. If you think, oh, what about the u and the u squared and the u? They're different. U squared, u, they're different. You cannot combine them. So let me just rewrite everything. My equal sign is going to come down. The right side is going to be u squared plus 2u minus 4. Now let's worry about getting u by itself on one side. I want to start by moving this u squared over to the other side by subtracting u squared. And when you subtract, it'll cancel out there. But when you subtract over here, it's also going to cancel out. So my new equation is 3u equals 2u minus 4. So my next step would be to get the u to the other side as well. So I want to get rid of that 2u by subtracting 2u. What I do to one side, I do to the other. I will get 1u equaling negative 4. And guess what? We're done. U equals negative 4. So if you understood that, you'll understand everything on the quiz this Friday. Make sure you finish every single one of these. Again, I have other videos that explain different problems, but you are responsible for completing every single one of these.